So in this story problem, we have a hot air balloon that's 100 feet straight above where it's planning to land. Sarah is driving to meet the balloon where it lands. If the angle of elevation to the balloon is 35 degrees from where Sarah's at, how far away is Sarah from the place on the ground where the balloon will land? So we have the balloon, which I'm going to do my best to kind of sketch here. So we got a balloon in the air here, and we got a balloon here up in the air, and it is a total of 100 feet straight above. This is 100 feet here. And we also know that Sarah is somewhere over here away from the balloon. We don't know how far that is. We're trying to calculate it. But Sarah's somewhere over here driving, so she's in a car. She's in a car, headed to the balloon. So we're trying to figure out how far that distance is. But we also know that the angle of elevation from the car to the balloon is 35 degrees. We need to figure out some sort of ratio here to calculate this value of x. So we have our angle of reference, which will be this angle of elevation here, our point of view, which means that the 100 feet is opposite. We have this distance here, which is our hypotenuse, and this, which is adjacent, which is touching it. And so once again, we want to create a trig ratio that uses the sides that we know and the side that we want to know, those two values. And so the ratio that we have is opposite and adjacent. So the trig ratio that uses opposite and adjacent is tangent. So what we have here is we have the tangent of our angle of reference, 35, will be equal to the opposite divided by our adjacent. So we now have this. The next step will be to go to my calculator here and type in the tangent of 35. And so I now know that tangent of 35 is equal to 0.7002. I'm just going to be a little more precise here, over x. Now, on the last problem, we multiplied both sides by the denominator here, but now our denominator is x. And if I were to multiply this by just that number on the top, I would get a length of 100 times 0.7002, which would be about 70.2. And it wouldn't really make sense for this side here to be shorter than the 100 with our angle being 35. That wouldn't really make sense in the context of this problem because that implies, with this side being shorter, that this angle up here is smaller. We know this is 90, and we know that all these angles have to add up to 180. This angle up here is, that would be 55. And since this is a bigger angle up here, I would expect this adjacent side to be larger since it makes up the larger angle. So it should be bigger than 100. And plus, if this was the value, then what we should get is that 100 divided by 70.02 should give us the tangent of 35, which is 0.702. We should be able to say that the tangent of 35 would be equal to 100 divided by 70.02. But if we look here, clearly the tangent of 35 is not equal to 1.42. So multiplying by 100 is not the solution. We need to follow our inverse operations. So in this case, 100 is being divided by x. So what I need to do is multiply both sides of my equation by x. So what that does here, so to multiply both sides of the equation by x, what I get will get x times 0.7002 equals to 100. And that's because 100 divided by x times x, those x's will cancel and we'll have this. Now to get x by itself, I need to divide by my ratio. So x is equal to 100 divided by my 0.7002, and that will give me my length. And so if I do that, get rid of these, I do 100 divided by 0.7002, I get my value of x equals 142.8, which is now my length, 142.8